little bit of a random challenge for you today, or this week, shall I say, where we're looking at lift trips that a lift might make. So we've got the time that those lift journeys happened, what floor they were starting at, and what floor they were going to. So our first step is to turn this hour and minute to fields into one date time field. So we're going to do that with the help of a calculated field. So if I zoom in on that, we're using the make date time function, and that needs a date and a time in order to make the date time, funnily enough. So we're using the make date function for making this the 12th of July 2021, just because that's what it says to do in the requirements. It could be any date here, to be honest. It doesn't matter because it's all on the same day. And then we're making time using hour and minute fields as our hours and minutes, and 0 as our seconds, to create just this now one field called time, which gives us all of our date time function rows there. And then we're going to create a trip ID based on this time, on these times, and I'm going to use the analytical function row number here. So I always have to go to the drop down, find analytical calculations and row number to remember the syntax here, but we're ordering by that time field we just created in an ascending order, so that the smallest or the earliest time is a 1 and the latest time is, I don't know how many rows there are in this data set off the top of my head, I think about 1,000 and something. But yeah, this will just make sure that we have a 1, 2, 3, 4, etc. and so forth. So that's great. We got a trip ID. Now we've got an issue because our floors include a basement and a ground, so we don't have actually the order that the floors go in at the moment. We've just got what they're actually called. So we're going to group by our from field and rename it to be floor for now, so that we can get that ordering associated. So we're going to break these up into the letters, so B and G, and the numbers. And I've done this using regex, but you could have easily used an if function logic as well to do this. But just to explain the regex, it's regex match, and it's saying in the floor field are the only characters digits, basically. So that \D means a digit, so the numeric characters 0 to 9. And is there one or more of those? So is it a 1? Is it a 10? Both of those cases will be captured. So my false here will just have my basement and my ground floor. My true will have all the numeric floors. So let's go ahead and start off with the basement and the ground floor. Let's categorize those. So we're just going to use a ranking function here to make the basement have a 1 and the ground floor have a 2. So I go and select rank there, and that brings me that pop-out window here, making sure they're sorting in an ascending order rather than a descending order. So the basement gets a number 1. And then we're just going to make sure that we get the maximum value here. So we're keeping it dynamic in this workflow as ever. So that then when we come to our numeric fields down here with our floors that we have, then we can just add on that maximum value once we've done a dummy join. So basically just having a field that's a 1 here, a field that's a 1 here, joining them together so we get that 2 on every single row. And then we can add our floor and our order together so that we can then union these together, and we have our distinct order of the floors. So our first floor is our basement, our second floor is our ground, our third floor is the first floor. You get the point. Okay, and then now I have these orders associated with each of the floors, I can then join them onto the from, join them onto the to, and then my data set is looking, it has numeric fields for from and to now instead. So I've got my trip ID, my numeric from, my numeric to, and my time, which means that I can calculate, how many floors are in between much easier now, because I can just use minuses rather than having to think about what number would ground be, and so on and so forth. Now you might have chosen to use the basement as -1 and the ground floor as 0. that's absolutely fine too. And I've literally only just thought of that now. That might have been quicker. But anyway, that's the way I've chosen to go about this so far. So now we're looking at, okay, let's look at our table that we've got down here. So for trip number 1, that's going from floor 2 to floor 10. And then the next trip is going to floor 6. So the lift would have to travel from floor 10 to floor 6. So that would be, it would have to travel 4 floors. So how do we make that calculation across those rows? Well, what we need to do is we need to bring our next trip up onto the same level as our current trip to make that calculation. So we're going to use this field here, and we're going to use our trip ID, and we're going to minus 1 off of that, so that our trip ID 2 would then become trip ID 1 in the next trip, as you see there, so that if we join that back onto itself, now this 6 can go and sit up on the row above. If we're joining our trip ID to our next trip, then the 6 would be on this row too. So we go ahead and make that join. Obviously, one of those things is going to fall out there, which is our very last one, because there isn't a trip following it. So we just need to make sure that we're doing a left join to bring those through. And then we can calculate that travel between floors. And we're doing that using an absolute function, and we're saying 2 minus next trip. Since I've renamed that floor, that number 6 floor, for example, to next trip, so that is that 4 that we were looking for. Now I can calculate the average travel between trips and just tidy the formatting of that up a little bit in the next step to get 4.43. So what that means is that any time I press to call the lift, I'm going to have to wait 4.43 floors on average for the lift to reach me. So is there a better way? What is the most frequent starting destination of our lift? Well, if I group by my from field here and count distinct on the trip IDs, then I can see the 1 floor is way more common than any other, and that's number 2, which corresponds to our ground floor. So I filter that out to just give me that ground floor. I mean, I do make sure that it's dynamic by using a fixed LOD to say what's the maximum count here, so the most frequent floor, and then filter to make sure that the most frequent equals the count, and therefore that 2 is my default position. Okay, so if I then join that up to my data set before I aggregated it to get that average travel between floors, then I can start calculating the difference between the default position and the starting position of the trip, so that I can know how, if the lift were to return to its default position after every journey, would that reduce the time that I would have to wait. So again, we're using that dummy trick where we have a dummy column to join it back on, because there's nothing kind of common between these things to join them together. And then we're able to calculate this travel between trips from the default position to the from, taking the absolute value again, averaging that once more, the travel between trips, keeping in our default position because we want that for our output, tidying up that, rounding it, joining our default position back to before so we can get the ground floor, doing a little bit of renaming, joining these together, and then finally calculating that difference for our final output. So just minusing off the average travel between trips from the average default position. And there you have it. It looks like you would have to wait 0.69 floors less each time if it were to return to the ground floor each time, which is interesting. Maybe that is the optimal way, maybe not. But thank you for listening to this challenge, watching, and I hope that you enjoyed it, and let me know if you have any questions. Thanks.